Hello my friend, welcome to my channel. Hope you all are doing fine. So in today's session we are going to see about HBase data model and its architecture. So let's start with what is HBase. So HBase is an open source distributed database built on top of the HDFS. It is designed for handling massive data sets, often referred to as big data. So basically HBase servers data lying on HDFS. Then why do you need HBase? We'll come to know after some time. And also HBase is inspired by Google's big table design. Next, about HBase key features. So these are all highly performant. So it is highly performant means if you need your data near real time, so you can go for it. And it supports memory caching, and most of the processing is done on the server side. And also you can integrate HBase with MapReduce, and you can process the data in batches. And next, it is fault tolerant, and because of that it is highly available. So even if some part of the cluster is not available, still it will respond. And it also supports automatic sharding and load balancing. So we will see this in later sessions when we talk about region servers and how exactly it will do the load balancing. Next, it is linearly scalable, and you can scale it using commodity hardware. Next, when you talk about usability, it supports flexible data model. It is not tightly coupled with schema, which is the major drawback we have seen in RDBMS. So at runtime, if you need new column, you can go for it. And also it is free and open source with a strong community support. So these are all HBase key features. And next we will see some of the common use cases for HBase. So if your data size is ranging in terabytes or petabyte, then you can opt for HBase. And if you are looking for high throughput for large number of requests, and also if you want to store unstructured data, and if you want your columns to be variable, and if you are looking for random reads and write, so these are some of the common use cases for which you can opt for HBase database. So if I want to give some examples of HBase where it is used, so in Netflix we have different playlists and collections, so they are using HBase for storing it. Another example is like personalizations and recommendations engines, such as in Spotify uses here HBase. Also messaging in Facebook uses HBase. So these are the few examples where HBase is used. So the difference between HDFS and HBase is in HDFS everything is batch process. So if you have 1 gigabyte of file and you want to pick specific line, then in HDFS it will parse or go through all the records. But in HBase, if you want a specific content, you can retrieve it quickly. So in HBase you can perform random reads and writes. Next, we'll talk about daemon processes in HBase. So from the diagram you can see the top blocks are for master services and bottom blocks are for slave services. So as you know that HBase follows that master and slave architecture. The blocks in green are HDFS services such as active name node, standby name node on master side, and data nodes on slave sides. For HBase specific, we have HMaster on master node and region servers on slave nodes. So your HMaster is master service responsible for coordination purpose and managing the metadata. We can see for HDFS we have active name node and standby name node, but for HBase it is not mentioned whether it is standby or active master, because it has the mechanism to elect the active master, and if one of the master goes off, then it automatically brings another master. So it is a quorum of masters. It provides mechanism for high availability of masters. In Hadoop, we have seen that name node is single point of failure and have to specifically implement higher availability. So HBase provides it out of the box. And you can see Zookeeper services. So these are coordinating services, basically responsible for running of your cluster. And your region servers are co-located within your data nodes. Region server is the primary entity which is going to serve you data for read and write. So we are going to talk in detail about each blocks in the upcoming sessions. Now before starting with HBase data model, let's go through the key terms. So we have a table. So table is a logical collection of rows stored in individual partitions known as regions. So for now, to keep it simple, it's a collection of rows basically. Next, row key. It is a unique identifier for the record. Then you have column family. So it's corresponding to row key, there is a column family. So it is a group of related values having similar attributes. Next we have column qualifier. So you can understand it as a different tag or name associated with each member of column family. So under one column family we can have multiple column qualifiers grouped together. Then you have cell. So cell is actual data value stored in column along with two more information, timestamp and version. So timestamp is the time on the region server where the data was when the data was written. So we are going to keep referencing these terms throughout the session. Now we have customer table in RDBMS, as you can see, and its corresponding structure in HBase. So you can observe that customer ID, which is a primary key in RDBMS table, it will become row key in HBase. Then you have a column families, which are a group of related attributes. So here we can see there are columns in relational database, first name, last name. So in HBase table it becomes this becomes column qualifier, first name and last name, and is grouped into one column family that is called name. Okay. Similarly, you can see block number, street, city and zip code. These are the independent columns in a RDBMS table, but here in HBase table these are grouped into, these are all column qualifiers grouped in together into a single column family that is called address. Okay. And your cell holds the actual data, along with it stores two more information, the timestamp and version. So HBase provides support to store multiple versions of the same data. Let's say for customer ID 1123, initially his location was, let's say, city center, and later he moved to IT park. So the address is updated. So if in later point of time, say if I want to know in 2020 whether the person was in which location, it's a city center or IT park, so I have the flexibility to get the information, and the versions are calculated based on timestamp, and each column can have any number of versions. So here in customer ID, which is a row key, they are all sorted based on string values, not integer values. So here 1123 and 1576 is coming before 23 because they are sorted lexicographically based on string values. Same for column family and column qualifiers. They are also lexicographically sorted. And the column qualifiers I don't have to specify while creating the tables. I need to specify only column families. I need to specify only column families while table creation. So the number column qualifiers are dynamic at runtime. We can add as many qualifiers we want. That's why it is called schemaless or flexible schema. And one column family can have millions of column qualifiers. And columns only exist, that is column qualifiers only exist when they are inserted. And each column family is flushed to one file that is called H file in HDFS. So in your HDFS, it is stored in the format of H file format. One more thing, in HBase you can store any kind of data such as numeral values or text values, but HBase will not complain. So for any, let's say column qualifiers, let's say block number, so you can say that you can see that we are storing numeral values 102, 123, and also for one of the customer ID we don't know the block number, so we have inserted don't know, that is a text value, but HBase will not complain. Okay, because HBase stores all the data in byte format. Okay, so internally all the data, whether it's a numeral, text, okay, it will be stored in byte format. So that's all about today's session. So in the next session we'll continue about HBase data model and its architecture in more detail. And please subscribe for more content like this. Like this video if you found it helpful, and leave a comment below and share your thoughts. Thank you very much. Goodbye.